Okay, it seems to be working now. We had a bit of an interruption there. I guess it's all part of technology. What can you do? Okay, so as I was saying, let's take a look at the reciprocal function. I'm gonna put in the key points. So I'll start with when x is -2, y is a -1/2. When x is -1, y is -1. When x is -1/2, y is now -2. So let's do some positive values. When x is 1/2, y is 2. When x is 1, y is 1. When x is 2, y is 1/2. So you only need, there are two branches on this graph because of the asymptote, and that results because x cannot be 0. So when x is -2, y is -1/2. When x is -1, y is -1. When x is -1/2, y is -2. So actually, you can just use those 3 points, and as x gets closer and closer to 0, it gets closer and closer to the y-axis. And I would hope you would know by now the y-axis, the equation for the y-axis is x equals 0, and that's because any value along the y-axis, the value for x is 0. And I'm just going to draw the graph this way, and this also as x gets larger and larger in a negative direction, this graph gets closer and closer to the x-axis, but will never touch it. So here, the equation for the x-axis is y equals 0, because every value along the x-axis, the value of the y-coordinate, or every point on the x-axis, the y value for the coordinate y value is always 0. Now similarly, we can draw the positive one. When x is 1, y is 1. When x is 1/2, y is 2. And when x is 2, y is 1/2. So we can just draw it like that. We have enough key points to draw this graph, and just very, very carefully do not touch either the x-axis or the y-axis, because the graph does not go there. You will find on a test that if you do touch it or cross it, you just be very careful that you don't. It will be a half a mark deduction. Okay, so as epsilon, this is the symbol for epsilon, and it's a symbol for epsilon, and this is a symbol for a very, very small value. So this is saying as x approaches a very small negative value, so as x gets smaller and smaller and smaller in a negative way, this becomes larger and larger and larger in a negative way. So this approaches negative infinity. Oh my, we're not doing well, are we, with our program? Let's just keep on going. As x approaches a very small value in a positive way, then y gets larger and larger in a positive way, and this approaches positive infinity. Now, as x approaches negative infinity, or gets very, very large in a negative way here, then y approaches 0. And as x approaches positive infinity, going in this direction, y again approaches 0. So what we can do now is just state our domain, x, such that x cannot be 0 because we can't divide by 0. X is an element of real numbers. And y, such that y cannot be 0. Y is an element of real numbers. So we again here, it will never equal 0. Notice if I plug in 0 equals 1 over x, and if I go to solve, I'm just trying to show you why y can't be 0. Notice that 0, if I cross multiply to solve, I get 0 times x is 0, and we're left with 1 on top, and you know 0 cannot equal 1. So y cannot be 0. Right? Y cannot be 0. It just doesn't work. Okay, so asymptotes, there's two asymptotes, x equals 0 and y equals 0. Maybe if I just move, no, it's just jerking around, isn't it? I don't know what's the matter with our program today. Okay, another graph I'm going to do with you, or the other function is y equals root x. So we cannot take the square root of any negative values, so there won't be any graphs on this side. So we're going to start with 0. When x is 0, the square root of 0 is 0. When x is 1, the square root of 1 is 1. When x is 4, I'm doing the easy square roots. The square root of 4 is 2. And then 9, 3. Well, even if we put in 16 for x, we won't be able to graph it. Now, what I want you to note, the way this equation or function is written, this is asking for positive square root only. It's only the positive square root. If it wanted the negative square root, it would look like this. So here we use the negative square root, right? So that's the difference. So don't be confused, because I know many times when you're solving equations, if you go x squared equals 4, your answer is x equals plus or minus 2, right? Because negative 2 squared is 4 and positive 2 squared is 4. But don't confuse this with this. They're two very different things. This is asking for the positive square root. Okay, so why don't we graph it? We have 0, 0, 1, 1, 4, 2, 9, 3. And so that goes like this. And there's our graph of the square root function. So, as x approaches a very small negative value, well, notice this graph does not exist on the negative side, so we're just going to go non-applicable. And for this one here, as x approaches a very large negative value, this is not applicable for this graph because we just don't have any negative values on this function. So as x approaches a very small positive value, right? Let me just write that up here, is a very small value. It's like 0.000000000000001. It's something like that, right? Very, very small. And hopefully you want me to move it up. Yeah, is that okay? So epsilon, just remember that. And infinity is a very large value. So as x approaches a very small positive value, thank you, y approaches 0. And as x approaches a very large positive value, y approaches positive infinity. Our domain is x such that x is greater than or equal to 0. X is an element of real numbers. And our range is y such that y is greater than or equal to 0. Y is an element of real numbers. Does it have asymptotes? No, they're not applicable. The only other thing that maybe students had queries about yesterday, especially when you do, I guess it was yesterday's work, notice that quadrants are labeled This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Just so you know. You would have ran into that yesterday. That's a common question. Again, this is 1, 2, 3, 4. You don't have to put that on your graph. I'm just doing that for teaching purposes this morning. You don't want to label your graphs like that. What you want to do is label your graphs y equals root x, y equals 1 over x, and that's about it. Is there anything I can explain better? So you are going to do other things. You're going to be doing the y equals x cubed graph. That just very briefly looks like something like this. You'll be doing the y equals x squared function, basic function, and you would know. Remember, this is x, this is y. That looks like this. And you'll also be doing y equals absolute value of x graph. And let's talk a little bit about absolute value. Absolute value is the distance distance value is from 0. Okay, it's just the distance is the distance. So if I were to draw a little number line here, and if I were to put 3 and -3. So let's look at the absolute value of 3. The absolute value of 3 is asking for a distance, and you know distance is always positive. So the distance 3 is from 0 is 3. And the absolute value of -3, well, the distance -3 is from 0 is 3. So this pump, regardless of what value is in here, this function, absolute value, always pumps out or produces a positive value. And you will learn more about that in grade 12. May I explain anything better? So you will be doing this and this for each of your graphs. I suggest you supply yourselves with your own grid paper. I can provide you with the templates. I don't really have them today. If you like, if you can wait for tomorrow, I'll just photocopy a bunch of templates. But the graphs, I think you can provide the grid just to save on photocopying costs. I don't recommend, again, as I said, don't use this one. This is very poor quality for the project you're handing in. Any questions before I sign off? Anything I can explain better?